So now we see another example. So here we are solving in the second example differential equation of second order by using Laplace transform. So y double dash means the second order differential equation. Now the two initial conditions are given in this. So as we know that we have to apply Laplace transform on it. So let's go to the step 1. Applying Laplace transform on both sides. Applying Laplace transform on both sides of the differential equation. Differential equation. So it means now we are working on this differential equation only. So what it gives you? Laplace of y double dash plus Laplace of 5y dash plus Laplace of 6y equal Laplace of 3 e power 4t. We are using the linearity property of this. So as you can see here, we have to use Laplace of double dash. So we are going to use the rules that if we denote the Laplace transform of y of t as fs, then we have Laplace transform of y dash of t as sf of s minus y of 0, Laplace of y double dash of t as s square f of s minus s y of 0 minus y dash of 0. Here it's okay, you can use f of s or x of s. So if you want, we can make use of say capital Y, not a problem. Okay, so let's use it. Capital Y of s, so here it is capital Y and capital Y. So when we start solving, we have to now solve it for three different terms. Say first term, second term, third term and fourth term. So let's begin with the first term. So it is Laplace of y double dash, which is equal to Laplace of y double dash means this formula. So it is same as Laplace of y double dash. So using this formula, it gives us s square capital Y of s minus sy of 0 minus y dash of 0. Now, in this equation, we have the value of y of 0 from here and y dash of 0 also available from the question. Let's substitute it. It gives you s square y of s minus s y of 0 is 1 minus of y dash of 0 is minus 1. So this gives you s square ys minus s times 1 gives you s, minus minus become plus 1. So this is the value of L y double dash of t. Okay. Now, so second term is Laplace of 5y dash. Now linearity constant multiplied with the Laplace, so we can take 5 outside. Laplace of y dash. Now we will use the second rule. So this is 5 times. Now as Laplace of y dash is having two terms, we should put a bracket here. So it is s y of s minus y of 0. So what I am saying, this bracket is important. If you don't put the bracket, you will get the wrong answer. So now substitute the value of y of 0 from the question. Here we are using only y of 0, not the y dash of 0. So this gives you 5 sy of s minus the value is 1. Now multiply this 5 inside. So this gives you 5 s y of s minus 5. So this is the value of Laplace of 5y dash. We find the value of third term. Third term is Laplace of 6y. So 6 is a constant, we take it outside, Laplace of y. So which is here, from here we get it as y of s. So this gives you 6y of s. And then similarly fourth term, Laplace of 3 e power 4t. 3 is a constant, take it outside, Laplace of e power 4t. This gives you 3. Laplace transform of e power 4t is 1 over s minus 4. So you can write it as 3 over s minus 4. This is the value of Laplace of 3 e power 4t. And here we have the Laplace of 6y. Now substituting these four values, value of Laplace of y double dash, Laplace of 5y dash, Laplace of 6y, and Laplace of 3 e power 4t in this equation. Let's substitute these values in this equation. For the first term, we have s square y of s minus s plus 1. For the second term, we have two terms, plus 5sy of s minus 5. Okay, and then again plus. For the third term, we have 6y of s equal to, we have 3 over s minus 4. So this is continued solution. Okay, so now what we have to do, we keep the terms involving y of s on the same side, and the terms not involving y of s. So y as involving term means this entire term will be here, this entire term will be here, and this total term will be here, and the other terms will move to the other side. So what are those terms? 5, it will go other side, 1 will go to the other side, and even minus s will go to the other side. Okay, so let's see what we will get then. When we do this thing, we are keeping s square pi s plus 5s ys plus 6y of s. This is on the same side. We have on the other side 3 over s minus 4. Minus s goes to the other side, become plus s. Plus 1 on the other side, it will become minus. Minus 5 when it goes to the other side, become plus 5. So let's solve it. This gives you 3 over s minus 4 plus s, and minus 1 plus 5 gives you plus 4. Okay, and then we solve it again like we did in the previous question. 3, we take LCM as s minus 4. This gives you plus s plus 4, s minus 4, because we solved it by considering it as, say, we divide it by 1, then cross multiply. Okay, so we got the term s minus 4 here. Similarly here we have ys, so we take ys as a common factor, and we'll see what we left with. We left with, in the first term, s square plus 5s plus 6. So Now when we want the value of y of s, we have to divide both sides by s square plus 5s plus 6. So this gives us 3 plus s plus 4 s minus 4 divided by s minus 4 s square plus 5s plus 6. Now here ys stands for Laplace transform of y. So it is 3 plus s plus 4 s minus 4 over s minus 4 s square plus 5s plus 6. So similarly, to get y, we have to take inverse Laplace transform of both sides. 3 plus s plus 4 s minus 4 divided by s minus 4 s square plus 5s plus 6. So what we did here, we applied inverse Laplace transform on both sides. Applying Laplace inverse on both sides. Now we know that if we want to take the inverse Laplace transform, again we have to make use of partial fraction. So for that we have to split it into two terms. We have to factorize it. So what are the factors? S plus 2, s plus 3. Because 2 and 3 are the numbers which on product gives you 6. When you add them, you will get plus 5. So as we have to find inverse Laplace transform for this, we can see three different terms in the denominator which are linear. So as per the rule of partial fraction, it is a over s minus 4, b over s plus 2 plus c over s plus 3. Again we add them together, s minus 4, s plus 2, s plus 3. This will be the LCM, because from the question we have the same LCM and same denominator. Okay, now we have to search for the term that should be multiplied with a, with b and with c. So again you can use the same concept like I explained in my previous class, that multiply all three of them with the denominator, s minus 4, s plus 2, s plus 3. So check, when it's multiplied with a, we already have s minus 4 below a. So you left with here s plus 2, s plus 3. With b, we already have s plus 2. So that will cancel out and we left with s minus 4, s plus 3. And for c, we already have s plus 3 which will cancel down. So you left with s minus 4, s plus 2. It is just the extension, like how we are doing it for 2 terms, here we will do it for 3 terms. So here we will get, comparing the numerators, 3 plus s plus 4 s minus 4 equals a times s plus 2 s plus 3 plus b times s minus 4 s plus 3 plus c times s minus 4 s plus 2. Okay, so as we have three constants a, b and c, we have to substitute three different values of s that we will get from the question. Again, denominator. So first will be s minus 4 equal to 0, which will give you s is equal to 4. Second will be s plus 2 equal to 0, which gives you s is equal to minus 2. And the third value will be s plus 3 equal to 0. That will give you s is equal to minus 3. So when we replace s here and we have more s, so be careful, like you should replace all the s's. By 4, what we will get? 3 plus 4 plus 4, 4 minus 4 equal a times 4 plus 2, 4 plus 3, b times 4 minus 4, 4 plus 3, plus c times 4 minus 4, 4 plus 2. So see, it's not necessary that every time you write such things. You can sometimes do it directly. Like what I am saying, 4 minus 4, you know that 4s minus 4 is 0, so this factor is going to be 0. So you can directly write 0. Here, as we are substituting s minus 4 0, it means this factor cancel out in b. So you can cancel it directly. Okay, you can simply write the non-zero term. Both ways are fine. Even if you write completely, it's fine. So this gives you a is equal 3 equal 4 plus 2 is 6, 4 plus 3 is 7. So when you simplify it, this gives you a equal 3 over 6 times 7. So which is a is equal to 1 over 14. Okay. Now replace s by minus 2. So it is 3 plus minus 2 plus 4 minus 2 minus 4. So as we know that s plus 2 factor is 0. So this term here becoming 0. And also the term in c is becoming 0. So you can do it direct. Okay. So okay, still I will write it. Minus 2 plus 3 plus b times minus 2 minus 4 minus 2 plus 3 plus c times minus 2 minus 4 minus 2 plus 2. So just do it carefully. Don't do mistake in terms of doing it directly. It's fine. You can write the terms. It will take extra few minutes, but at least you are sure that you didn't miss any term and you are doing correct things. So it is 3 plus minus 2 plus 4 is 2. When we replace s by 3, s by minus 3, what we will get? 3 plus minus 3 plus 4 minus 3 minus 4 equal. Now s plus 3 0, it means this term will 0, term with b with 0. So a times 0 and then with b also 0, we get c minus 3 minus 4 minus 3 plus 2. So this gives me 3 plus 1 minus 7, and here c minus 7 and minus 1. That will give me 3 minus 7 and here 7c. So this gives me c as minus 4 over 7. Let's substitute these values of a, b, c here in the question. So a is 1 over 14. 1 over 14 s minus 4 plus b is 3 over 2 s plus 2 plus c is minus 4 over 7 s plus 3. This was the value of 3 plus s plus 4 s minus 4 divided by s minus 4 s plus 2 s plus 3. So now we were looking for the value of y, which is Laplace inverse of 3 plus s plus 4 s minus 4, and the same term that we are writing s plus 2 s plus 3. It is same as finding the Laplace inverse of these three terms. 1 over 14 s minus 4 plus Laplace inverse of 3 over 2 s plus 2 plus Laplace inverse of minus 4 over 7 s plus 3. Now applying the rule in for each term, 1 over 14, this gives you e power 40. 3 over 2 e power minus 2t, and minus 4 over 7 e power minus 3t. So this is the solution of given differential equation.